Okay. And let's see. I think on the previous lesson, I said take a screenshot and quickly try to do or answer that example, the questions on that example. So I'm definitely going to take you through those calculations with reference to the lessons that I've done, the two lessons that I've already completed. So under this example, they are talking about an object which is suspended from a ceiling by two cords, as shown in the diagram below. Yes, we can definitely see that we've got an object there of 3 kg, which is suspended from the ceiling by two cords. So what they want you to do is just to determine the magnitude of tension 1 and tension 2. Very much important on that one. I will try to very quickly do a drawing of that. So let us say this is that a ceiling. And then what are we having there? Let's say we have that cord there and we still have another one there. And this is that object of 3 kg. Very much important on that one, honorable member. Most importantly, we do have our angle there being 60 degrees and then that one being 35 degrees. Very much important, honorable member, on that one. Okay, so now, firstly, let us try to draw a labeled free body diagram where we do a dot. The dot representing that object of 3 kg. Obviously, each object has got a weight or a force downwards as a result of a gravitational acceleration. So that is Fg, or otherwise you can say the weight. And we do know very well that the formula for that is equals to mg. The g because of gravitational acceleration. And then we have that cord. The cord is exerting a force in that direction. So that is where we talk about tension number 1. And then we will therefore, this is cord 1 for tension number 1. And then we have another one in that direction, being the second cord. We will therefore refer to that as tension number 2. Very much important, honorable member, on that one. So what I'm going to do now is not what you need to do if you were asked to draw a free body diagram. But I just want you to remember that this is where it is attached to the ceiling, whereby that angle there, it is 60 degrees. And then here, it is where it is attached to the ceiling, whereby the angle there, it is that one of 35 degrees. So why is it important for me to emphasize that point? It's because, it is definitely because we might need to draw that force triangle, because it is the one that we are going to use in order to make use of the sine rule to determine whatever that we may be expected to determine. Very much important, honorable member, on that one. Maybe very quickly, let me do this and say, when it comes to force triangle, yes, I think it's a force triangle. Remember on the previous lesson where we had to do the manipulation. So we have to manipulate those forces and draw them in a form of a triangle, whereby we definitely have the downward force. Do we not have that downward force as a result of a force by a gravity, which is equals to mg, that we know, which is equal. Definitely, what is the mass? The mass, they said, is 3 kg. Let's just multiply it by 9.8 so that we can just immediately calculate its value in terms of the weight. So we just say 3 multiplied by 9.8, we get 29.4. Most importantly, in Newton, because this is a force, 29.4 Newton. Yes. Okay. then it's fine. So which other force do we need to manipulate? I think it is this one of tension number 1, which is going in that direction, whereby this is that force going in that direction for tension number 1. So to complete that triangle, that's if we therefore have that other force in that direction, which is the one for tension number 2. So remember what I've explained regarding the angle. So that means for that one of tension number 1, this is where you are having that ceiling, whereby we said the angle that is formed there, it is 60 degrees, isn't it? So that one for tension number 2, definitely that angle, it is that one over there, which is 35 degrees. I hope that part makes sense, honorable member. Okay, if that is the case, let's do further manipulations. To say, I'm not sure if you remember, but there is that Z thing which is formed over there. And we do know very well that when that Z thing is formed, this angle should therefore be equal to that angle, which means automatically we have 35 degrees there. So that means this combined angle, it is 35 plus 60, which is it 95? Yes, it is 95 degrees. Let me just write it in red to say that combined angle, it is 95 degrees. Okay, we are very much interested in the inside angles because these are the ones that we are going to use when we need to apply the sine rule. So that means very much important that we know what that angle is, that inside angle. How are we going to know? Remember, if you are having a 90-degree angle there, and already this is 35, that means this one, it will definitely have to be 55. So that we know that when we take 35, we add it with a 55, it will therefore have to be 90 degrees. So I think with us having that angle, it should therefore be easier to know what that angle is, because the inside angles, when you add them together, they must add up to 180. So that means 180 minus 55 minus 95, we get 30. So that means that angle there, it is 30 degrees. So can you see, we now have a clean triangle, whereby it's like, this is now what you are having, the manipulated triangle, whereby this angle, it is 95 degrees. This one, it is 55 degrees. And this one is 30 degrees. Most importantly, we have this side being 29.4 Newton. So now it becomes easier, honorable member, because we are definitely having tension number 1 there and tension number 2 there, which is what you are looking for. And this one, if you remember, it is our value of Fg. So that's what we needed to do to find what that inside angle is, that one and that one, so that we can easily use the sine rule, whereby if it is tension 1 that we are going to be looking at, we will just say tension 1 should therefore be equals to sine of the angle which is opposite tension 1. This is the angle, which is that one of 55 degrees. This should be equals to, we will therefore equate it to Fg, because Fg, we already know what that value is for the Fg. And then we will say sine of the opposite angle being 95 degrees. So now let's substitute. Okay, tension number 1 is what we are looking for, divided by sine of that 55 degrees. And then Fg, already we did calculate it to be 29.4. Then that is being divided by sine of 95 degrees. Then you just cross multiply. That means your tension 1 will be equals to 29.4, where you multiply that sine 55 degrees, and the whole of that is being divided by a sine of 95 degrees. And that should be equals to, let us see. So we have 29,4 sine of 55 degrees. And then this should be sine of 95. Okay, this is what we are getting, being 24,18. This is in Newton because it is the force. Let's see, 24,18. Yes, even on the memo, it is the same calculation. So that means this is how you would therefore work it out. So it therefore means we know now what that is 24,18, you must say Newton, because it is the force that you are calculating. So very quickly, let me just insert a blank page there and then jump on to attention number 2. Again, not that much complicated. Let's see. So that means here you will still see your tension 2. This time around, it is equal to sine of 30 degrees because it has to be the side over the angle or sine of an angle which is opposite to that side. Just like we did with this one, we said this side we divide it by its opposite angle. That's how the sine rule works, which means here we're going to equate this to that FG, which is 29.4. Then we're going to divide it by sine of, again, 95 degrees. Then all that we do is just to cross multiply. So now we have that 29.4. This time around, we multiply it by sine of 30 degrees, which is being divided by that sine of 95 degrees. Punch it on your calculator. Let's see. It looks like I will just have to go back there and then update the angle to 30 degrees, and I'm getting 14,761. When I round it off, then this one it becomes a Newton because it is the force that we were calculating as a tension. Okay, that is, let's see. Yes, it definitely looks like that's all, honorable member. Okay, I will just have to end it here and say until we meet again. Until we meet again. Looks like